Hello, YouTube. Sidekick here with another installment of It's Not You, It's ME, my occasional series of videos on the mission editor in DCS. And this is actually going to be the second video about using scripts in the mission editor. So if you haven't watched the first of these videos introducing scripts, you might want to go look at that video now. This will probably make a little bit more sense. In that video, I introduced the idea of using LUA scripts in DCS and proved that it can be done without having to sell your soul to some darker power. In fact, all we did in the last episode was we just wrote a simple script. I think it only had 2 lines. We called it from the trigger system, and what it allowed us to do is to actually command a unit to spawn at a random location on the map. So today we're going to get a little bit more complicated, but to do that we're going to have to write a little bit of honest-to-God computer code. So I'm going to grab the whiteboard here because I want to spend a little bit of time talking about LUA, which is the scripting language that DCS uses, and some concepts of object-oriented programming, which you may have heard of, but which you do need to know to make any kind of sense out of what we're going to do now. I will issue the usual caveats to say that I do not write computer code professionally for a living, and I am strictly an amateur at this. If you are a professional, you feel free to be horrified by anything that I say, and if you have some constructive comments that you want to add in the comments, I'd love to hear them. But I do want to talk a little bit about object-oriented programming because there just are some terms we need to know in order to make sense of the documentation that we're going to find when we look stuff up. So this isn't really going to be a deep dive, but just a quick introduction. According to Wikipedia, object-oriented programming is a programming paradigm. It's been around probably for 25 or 30 years. When I started learning how to code, it was not the standard, though it has kind of become the standard, I would say. Anyways, we don't need to go into all of that. We just need to understand that when you're dealing with an object-oriented programming language like LUA, there are some concepts you need to understand. The first of which is something called a class. A class is basically a definition. It defines the properties that any member of the class must have. So when we're looking at documentation and we see references to class, it's going to be talking about a collection of objects. So objects are specific instances of the class. So when we create an object, because it's a member of a class, all we have to do is say that it's a member of that class, and then we know all of the properties that it will have. And that's kind of the power of using this approach, is that if you have a bunch of objects and you want them to share a bunch of properties, then you define a class, and then every time you define an object, you say it's a member of that class, and then you know a lot of things about it. The final term we need to understand in object-oriented programming is a term called a method. Now, a method is basically a function that operates in a particular way on any object in a class. Because it's a function that's specific to that class, in object-oriented programming, they call it a method, but it's basically just a function that's specific to a class. Okay, all of that's getting just a little bit more code nerdy than I think we really need to get. Hopefully it will become a little bit more obvious as we start writing some code here in a few minutes. Before we start doing that, there's just a couple more things that I want to talk about, and those are things that are specific to LUA. So here are some things we need to know about LUA. LUA is the scripting language that DCS uses. A lot of games actually use LUA. I don't really know that much about its origins, but what makes it special, although you can look that up. If you want to know more about LUA, there are lots of good guides to LUA out there. I'm not going to bother recommending one. You can Google it and find one that suits you as easily as I can tell you. But there are a few things about LUA that we really do need to remember. The first of these is that LUA is case sensitive, and I will say that again. LUA is case sensitive, always and forever. It matters whether or not you capitalize words in LUA. The other thing about LUA is that all reserved words in LUA are lowercase. So If, for instance, is spelled with a lowercase I. End is spelled with a lowercase e. For is spelled with a lowercase f. The Boolean value true is spelled small case true. Everything in Lua that is a reserved word is spelled in lowercase, and Lua is case sensitive. I'm saying it over and over again because I guarantee you there will be a time when you forget. The other thing to remember about Lua is what is referred to as weakly typed. And for people who know a little bit about programming, this means that in Lua, you don't have to declare variable types before you start using them. So you don't have to say whether a variable is an integer, a real number, or a string before you start using the variable. Now, the issue that makes it very easy, very flexible, but the issue is that when you combine being weakly typed with the case sensitivity, it means you have to be really careful about using the right variable name, because if you use the name of a variable but you change the case of it, of any of the letters in it, then Lua isn't going to know that it's actually the variable you're already using. It's going to go looking for another variable. If it doesn't find it, it's going to generate an error, probably the most common kind of error that you get in Lua. So remember, Lua is case sensitive and it's weakly typed, so keep track of how exactly you are spelling your variables. Let's see if there's anything else we need to remember about Lua. I guess one thing to notice is that all sort of extended statements in Lua, sort of multi-line statements, are simply terminated with the end statement, lowercase e n d. That means that all functions, all loops, all if-then-else statements, everything just ends in end. Also, Lua doesn't care about carriage returns or indents, which does make it kind of easy, especially with the Lua editor, to write code that's very readable, because you're free to redistribute the characters, on the line any way you want to, and to insert line breaks wherever you like. Finally, the other thing in Lua is that comments are denoted by a double minus sign. So if at any point on any part of the line you put in a double minus sign, everything after that point will be treated as a comment, and so obviously not as executable code. Okay, let's take a quick look at what we were doing last time. In the mission editor, we had made a little mission, and basically all we had done was we had a group here. It was basically some bunkers and some guard towers. And we had defined some zones around the island, and we basically set up a trigger and code that would basically spawn that group randomly. In fact, what we did was, just to test it, we had it spawn itself once every 3 seconds. And to do that, we used this little Lua file, Lua code fragment. And let's go take a look at that in ZeroBrain. And it basically, all that it did was it defined a variable called Z, which was a table. A table is denoted in Lua by the curly brackets. The table that contained the values of the names of the zones. And then we called this function miss.respawn in zone, which we found on the Hoggit wiki, which was a function that basically randomly spawned that group somewhere inside one of those zones. Now, just before we go on today, I just want to open a slightly updated version of this mission. Doesn't really look that much different, but there's a couple of things. The first thing that I wanted to replace it, because there was a good comment on the video the last time saying that in DCS you no longer simply have to use flag numbers. You can actually use flag names. So I have actually changed my trigger system here to refer to the flag we're using here as timer as opposed to flag 1. I wanted to show you that because I think that's an important update, and one that I had kind of missed. It's actually happened since I started making these mission editor videos. So that's a good thing to remember. The other thing is that I changed the Lua code just a little. So I added one more line. So we now have the local variable Z, which is a table that has the spawn zones. But I also made the name of the ground unit a local variable called ground1. And then when we call the function, we just use both the variables. This is helpful because if, for instance, we ended up changing the name of the ground unit, wouldn't have to go looking for it throughout the code. It would be a variable defined at the top of the file, which is just kind of good practice. So the effect of that is no different, doesn't change what the function or what the mission does. So we'll just run it to prove that we still just get a randomly spawned unit that shows up in a new location about once every 3 seconds. So to see it spawning, we have to go to F10, pull back a little bit. And there we see the group spawn over there, and then there. And so every 3 seconds, we're getting a different location somewhere randomly within the zones that we define. So it's working, just like it was before. So let's go back to the mission editor. Okay, so that works, but it's not, and it's an interesting way of testing writing Lua code, but it's not really a very interesting DCS mission. So let's think about what we could do to make a slightly more interesting mission. Let's say what we were going to do was, instead of just having the unit here and it spawned, let's open another slightly more complicated mission here. This time, let's say we're going to have an OV-10 Bronco that flies in. That OV-10 Bronco is going to be armed with some white phosphorus rocket pods. And so eventually what we want to have happen is that the OV-10 will fly in, the enemy unit will spawn in a location, the OV-10 will locate it, and then we'll fly in and we'll mark the target with white phosphorus. And then maybe eventually we also get to the point where maybe we're flying the attack aircraft, we have to spot the white phosphorus and then maybe attack the unit. But for now, let's just take a look at the next step, which is adding the OV-10. And so one of the things that I want to talk about here is let's just do this. Let's just put the OV-10 Bronco in. Then let's spawn the unit in. And this time, every time we spawn the unit, let's actually use Lua to extract some information from DCS, which is another thing you can do in scripting that's much harder to do with the trigger system. So this time, let's say what we're going to do. Well, let's just run it. I'll show you how this works. So the OV-10 is going to start our enemy unit. There's the OV-10. Our enemy unit is going to spawn in, and every time it spawns in, we're going to get it to tell it where it is, and we're going to calculate a range to the Bronco. So we're still using the same system where we're changing this every 3 seconds. This isn't what we're going to do in the mission. It's just a way of demonstrating what we're doing. So every time the unit spawns in, it gives us its location in meters in DCS, and it gives us a range to the target. And this is just demonstrating that we can, in fact, be extracting useful information here from DCS. So let's go take a look at how we manage that through the triggers and the scripting. So triggers don't really look a whole lot different than before. We're using a slightly different Lua file this time. So let's go take a look at what that Lua file has in it, because that's where all the differences are. So here is the Lua file that we're using. The first thing that you'll notice that I've got a little thing, a little local function here at the top that has been minimized. I'm going to talk about that in a minute. Let's just leave that for the time being. The other lines in the code, starting at line 15 and 16, are exactly what we had before. We've added another local variable called U, which is actually the unit name of one of the units. It's the main bunker in the target or in the enemy group, because we need to talk about units, not just groups, when we're talking about locations. In DCS, groups don't have a location, only units have a location. So we need to talk about a unit. Similarly, we've got a variable here named A, which is the unit name for the OV-10 Bronco. Now, then we spawn the unit just like we used to before. Now we have a new local variable that is something called unit lock or unit location, and it uses this little statement here that comes from DCS. So let's take a look at how we construct that statement. It's unit.getByName, and then U, which is the name of the enemy target unit, :getPoint. So let's take a look at the getByName function, which could be group, unit, static, or static object. And what it says is that the getByName function returns an instance of the calling class for the object of a specified name. So if you remember our object-oriented programming, basically, if we call this unit getByName, then it's going to return an instance of the class of unit. In this case, it's going to return the record for the unit that is the main bunker in the target object. Right? Because our unit, we're calling unit getByName, we're passing it the name of the unit in the enemy group. This is the main bunker. So it's going to give us, it's going to return that value. It's going to return that instance of the unit. And then what we're calling is another function here called getPoint. So when we, in DCS or in LUA, when we put a colon getPoint, getPoint is technically a method, a function that is run on a unit. So we're getting the unit here, and then we're running a function called getPoint. So what does getPoint do? So getPoint returns something called a vec3 table, which is the x, y, and z coordinates for the position of a given object in DCS's three-dimensional space. So when this one statement here does a whole bunch of things, or it's actually set up to be the definition of a variable, but what it's doing is it's also loading that variable with the x, y, and z location of the enemy unit. Okay, so let's take a quick look at how we actually, what that unit location variable actually consists of. So if we go back and look at that getPoint function or method, it is returning something that a vec3 table. So it's actually not returning a single variable. It's returning a table of variables. That table has three values, an x, a y, and a z. Now, it's an important thing to remember in DCS that in the vec3 table, x is the north-south location, y is the altitude, and z is the east-west location. So we denote the values in the table by putting a dot after the variable name unit lock, and then the name of the coordinates. So unit lock dot x is the north-south location of the bunker. Unit lock dot z is its east-west location. And what we're doing here is we're printing this out using something called trigger.action.outText, which is essentially the same as a message to all function. You can see it defined here. The important thing to notice in Lua is the way it's constructed. So anything that is in quotation marks is going to be printed directly. The two dots are a concatenation symbol, which basically means that anything after the two dots, in this case, the variable unit lock dot x, is then going to be printed. Then we have another concatenation. Then we have a space between the two quotation marks, then another concatenation symbol, and then unit lock dot z. So that means the net result of all of this is that we're going to take the north-south location of the unit, east-west location of the unit, and we're going to print them with a space between them, and we're going to write bunker location in front of them, which you will have noticed is exactly what you saw on screen when the mission ran. Okay, so we have got the bunker location. Now we actually want to get the range from the bunker, wherever it spawns, to the plane. And this is a useful thing to do, partly because I just want to show you how we can actually write our own function to do a calculation within LUA. So the first thing that we need to do is actually figure out where the plane is, and we do exactly the same thing as we did up here where we find the unit, except we find the plane, and we store that in a variable, a table with three values called planeLock. Then what we're going to do is we're going to call our local function called getDistance3D. So this is a function we wrote. We have to put that function above the rest of the main code. So any local functions that you write have to occur before the main executable code. So we wrote a little function called getDistance3D. Essentially, we pass this function 2 points, two vec3 tables. You can see them here. And then it basically does the math to do a root sum of square distance between those two points, and then it gives us back that distance, which we then store in the variable called range to target. So we pass it the plane's location, we pass it the unit's location, it tells us the range between the two, and we do another trigger.action.out text to print that range on the screen. And the little 3 at the end of these means that they only show up for 3 seconds, which is why they disappear periodically on screen and then are replaced by the new values. So let's go back to the mission editor, and let's just run that file one more time and watch what it does again. Now that we know how the code is doing it, there's our OV10. And there you see the bunker comes up. It tells us where it is, and it tells us the range from the Bronco to the enemy bunker. Okay, I'm actually going to leave it there for today for this second episode in the introduction to scripting. I realize we're taking small bites one at a time here, but I really do want these videos to be around 20 minutes long, so there's not too much going on in each one of them. And the next concept that we're going to tackle is actually making that Bronco do something useful, like fire a rocket at the target. And that requires now we're starting to get into a slightly more complicated Lua programming. It's going to require using a function called setTask that has like a nested table in it. At any rate, I don't want to get into all of that. In this version of the video, that'll be the next episode in basic scripting. We'll show how to actually take that Bronco, have it attack the target, and maybe we'll actually add a little bit of randomness so it's not actually attacking the target, it's attacking somewhere close to the target. And then, basically at that point, we'll be ready to say that we have a mission where we could fly in as the player, see a smoke mark on the ground, and attack it, but that smoke mark is going to have some variation to it as to whether or not it's actually on the target. So that's what we're working towards. Probably wrap this up in probably one more episode, I think. So stay tuned for that. If you are enjoying these videos, please do like the videos. It really does help. Leave a comment if there's anything you didn't understand or something you'd like to hear more about, or if in fact you are a bit more of an expert in coding and you have some constructive advice for the rest of us. We'd certainly like to hear about it. But for now, this is going to be Sidekick, signing off.